Thank you all for joining. We're gonna wait maybe like 1 or 2 more minutes before we start because people are still trickling in. And then we'll get started.
Good afternoon.
Oh, yeah, thanks for joining. I don't actually know who said that. But
It's Roger
hello.
here, an hour earlier than expected.
Roger's here. Okay, great,
Yeah.
Roger.
Good. It worked out in the end.
Good.
Perfect. Well, I
Yeah,
guess
hi,
then it
Roger.
looks like we're pretty good to start. I'm glad, Roger, you're able to join on time.
So am I. It was all we finished early. It's a pleasant change.
Excellent.
Perfect. Nice. Yeah, so thanks everyone for joining. This is the first webinar online meeting we're having for the New to Trenchless program of 2026. So this one is on new installation, which will be a good topic to cover that Tim and Roger and Peter will be getting into the nitty-gritty of. I don't know if, I guess when everyone speaks, they can introduce themselves, but I'm Silvana. I'm the program lead for this for New to Trenchless. And then we have Tim, who's the vice chair of the UKSCT, who's going to be giving the overview, Peter from Volker, and Roger from Tractor Technic, who are going to be our experts on the deep dive. So really quickly, we wanted to kind of recap on the next slide from what the UKSCT, housekeeping first. This is all the fun logistical stuff that I think everyone's probably seen if they've come to one of these meetings before. But yeah, please stay muted if you're not speaking. We are recording this, so we'll circulate the slides and the recording after the meeting. I know there were maybe some people that weren't able to join, so we're going to be sending out the recording to them as well. Yeah, just to ensure that you have those, please ensure your contact details have been provided to admin at UKSCT. If you've registered, we already will have them. The aspect of this program is also on CPD. So if you would like a CPD certificate if you've attended this, please email admin at UKSCT for your copy. And yeah, so we'll record the presentations. So yeah, all the good housekeeping, not on the slide, but please, if you have any questions throughout the presentations, either raise your hand using the Teams function or put it in the chat, and one of us will be able to have it answered while we're talking about that technology. So yeah, kind of what we're going to be talking about today. We'll update for what happened in 2025, great year for New to Trenchless, what we've got planned ahead for 2026. And then, yeah, Tim will give an overview of trenchless options. Peter will kind of come in as the expert on directional drilling, and then Roger will provide an expert view on online renewal. We'll then have a discussion, Q&A, and close. But like I said, if you have any questions during the 3 presentations, raise your hand, put something in the chat. Happy to chat it through during the presentations. So I am not sure if anyone here, this is their first New to Trenchless experience, but if you came to any of the events in 2025, you saw that we were pretty busy. So we had 5 online webinars like this one in 2025. We introduced the network, went over new installation, rehab, investigation and assessment, and the benefits of trenchless. So we had those throughout the year with some great experts and some great engagement on those. Another aspect of what we did in 2025 and what we'll look to continue to do in 2026 was in-person events, often tied in with a no-dig, roadshow or other UKSTT event. So there was a visit down to Wessex Water to learn more about some of their programs, visit up with the No Dig Live in Sheffield to Pipebots and the University of Sheffield there to learn about the underground infrastructure facility there. And then at the annual conference and No Dig Road shows, we had more in-person networking. So thank you if you came out to any of the in-person events as well. It was great to meet people in person and also online in these events. So we had over 125 participants in our events last year from over 70 different organizations across the trenchless space, which was really exciting to see. And we did a bit of a survey to see what was working, what wasn't working, and got some really good feedback on these sessions. So hopefully we can continue some of that exciting work that we did in 2025 into 2026. So on the next slide is what we've got planned for 2026. There's a lot on here, but some of it is directly related to the network. Others are associated events, but we're going to shout it out all anyways. So this is the first of the online webinars, and we are planning 4 more throughout the year. You probably already have the dates, but if not, a reminder. On March 26th, we'll be on rehabilitation and a focus on non-CIPP methods, because the one we did last year was more focused on CIPP. On May 14th, we're doing site investigation and condition assessment. July 16th will be focused on infiltration, and November 19th will be rehabilitation with a focus on CIPP. Those will all be at this time slot, 2 to 4 on Teams, and we'll circulate the meeting links beforehand. So it'll be similar structure to this one. Will be an overview and then have expert presentations on their experiences with those technologies. Some other associated events, which will be great if you're looking to learn more about trenchless, how we interact with other industries and things like that, are these 3 associated events. So on January 28th, there's an IWA ISTT webinar on an introduction to trenchless. So that will be a bit of a collaboration. And I believe if you'd like that link, you can contact admin at UKSTT. I don't know what time that will be at. Apologies. But that will be a good webinar. On March 3rd is the UKSTT annual conference, so that'll be a mix of presentations, some exhibitions, and networking. I believe it's the 3rd annual. Maybe Lynn, correct me if I'm wrong, but it's been great the past couple years. On April 29th is a masterclass technical event. So if you are interested in learning even more than you will today on new installation and renewal and new trenchless, that is a great event that I know Tim is running, so he can probably provide a bit more information on. And then we have the No Dig Road shows throughout the year. March 12th is in Dublin with exhibits and a presentation conference program there. Similarly, May 12th is in London, and July 8th is in Glasgow, and then September 29th to October 1st is No Dig Live. We're hoping to have a special event for the New to Trenchless Industry program at No Dig Live, so stay tuned for that. And yeah, if you'd like any more information on those events, contact admin at UKSTT, or if you're curious, feel free to put something in the chat. I think that is all of kind of like the logistics side from me, so I'll hand over to Tim to get into new installation.
Okay, first question is, can you hear me okay? I've got my tannoy there, but I don't know whether, is that clear and the slide come up okay?
Yes, all good, Tim.
All good? Okay, so what I'm going to do is we very much see new to trenchless in terms of a group of individuals that have joined this, as those are really interested in being educated on a quite a broad spectrum of what trenchless is. And then in this instance, we've coined it around, or we've positioned it around new installation. In reality, there's a blend between installing new stuff and renewing stuff often installation of new is because existing assets are failing, and often reinforcement in the network takes place. So we are going to blend in some other technologies into this presentation, which will look at pure new in the ground, effectively, which we'll go through, but also some complementary technologies around online renewal, because ultimately you end up with a new asset. So I'll get going. I think the first thing to recognise is that just to give you a flavour for the industry, the important thing to us is that we are covering a huge diverse range of techniques and operations. And also we're covering a huge variety of asset networks. Left-hand side, there's a few clues on there for those of you who are familiar with the networks, but it is extensive. And one of the things we do find in the new two groups is comparative technology between different sectors that might be used in the gas industry but not being adopted in the water industry. Something that is a perfectly brilliant technique in the water industry that could be used in the electricity industry, for example. So we are very aware that we need to cross-fertilize. So that's the first thing. Second one is we're not going to talk about so much about rehabilitation today, but rehabilitation of existing pipes is a huge part of what this industry is about, and alongside the new and the renewal. Clearly, the other thing that we need to recognise as a community on the right hand side is the diverse range of different people that are involved, whether that's on the design side, whether it's the owners of the networks themselves, the contractors, specialists, even academics now with some of the brilliant stuff that's going on with the investigation using AI, and clearly stakeholders such as the highway authorities and the Environment Agency and other agencies wherever you are in the world that have an influence on what happens but may not be the paymasters. So I just want to raise that because we can learn from each other, and we can learn from other sectors and the whole industry as a whole. Next one I just want to touch on is why bother. We're finding that traditionally trenchless came from a background of not digging the road up. Now that's perfectly valid, and we continue to reduce the type of reinstatement and excavations in the road, but there are huge other benefits, and I'll just draw out one of them. One of them is time. Some of the programs are quite significant, and the productivity that these techniques can offer the industry is in excess of anything that you could undertake with a traditional trenching operation. So that's one key thing, is that productivity using these techniques can be quite phenomenal. In my early days in my career, I did quite a lot of directional drilling projects, and I would invite clients when it was all new and shiny and very exciting to come and visit the job and warn them to come early. And some of them wouldn't take that note and would come late in the day, and the project was completed. So productivity is an area to look at. The other thing to look at is programs. Projects which are undertaken by trenching can take significant lengths of time on an overall program. What we've found with trenchless is there may still be disruption because of access, because of stringing out pipe and other things. However, a program I know in London that was going to be 3 years was cut down to 9 months by using trenchless. So again, just a small point, but something that we like to raise as a society and educate people about. The other thing is, I just want to mention as an intro is it innovation or is it business as usual? We have this dilemma where we talk about things being innovative and then we frighten a lot of people away. I don't know how many people on this call are really new to trenchless, but often by saying it's innovative, we then scare people because they don't want to be the first one to use it. Most of the technology, in fact, pretty well sure most of what I'm going to show you now has been around for 40 years plus. So don't be too scared. It's all about knowing which technique is appropriate and which process would offer you the best outcome. The other thing is we often get this other message that comes through is we would have loved to have used it, but it was all too late and we'd already committed. We would encourage you guys to think about it, the first thing you think about, and to engage really early. This crib sheet I've pinched off Severn Trent Water, and what they do is they encourage their design engineers to have a look through. It hasn't got everything on it, but what they try and do is encourage people, have you considered all these things before you even think of putting a trench down the road or through that field or whatever it might be. So thinking early and engaging early is really important. And this, I guess, is my point. This scares me, this slide. This is a project I was doing in 1990, and I have to pinch myself, that was 36 years ago. And this was the M40 motorway in the UK and hadn't been used yet. They'd built it and left quite a lot of communication ducts out, which wasn't helpful. So we went off and installed those ducts by trenchless, as that tarmac was very green and had never been used. So I'm going to run through a snapshot of different techniques, and we'll whistle through those now again for to give you a flavour. Some of which you guys will be even more familiar than me, I'm sure. But my job is really to inform you and educate you about the options. One sort of health warning, particularly with new installations, is absolutely critical. Going back to my first point, it's well worth noting ground conditions. Ground conditions can be a huge challenge if you haven't got the data. It's not that you can't use these techniques I'm going to go through. It's knowing what the ground is can determine, one, the type of technique you might adopt, and indeed the equipment that you might use. So you've got the method, but the sort of tooling, or if you like, the cutting heads or whatever you might use to install the assets, actually can be determined by ground. So spending time on understanding ground conditions is really, really important. And it will pay an absolute dividend. Where we have failings in the industry are often down to lack of information and knowledge. But that data is really invaluable. So I'd really call out to you guys to consider that on your projects. And the cost of getting that information is minute compared with the huge benefits you'll gain by having it to hand. So I get now I've bored you to death with that lot. I'm going to go into some details. Now, often when we think about building stuff underground, I'm a civil engineer by kind of trade, as it were. I think of these sort of things often default to the mega projects, big tunnels, big machines, and big projects. Well, that's probably why people don't adopt trenchless on occasion, because that's what they're thinking. But in trenchless, if you're doing trenching work, it's a huge diversity, and it's the same for trenchless tech. Whether you're doing very small stuff or medium, you can see that pipeline job there in the middle. Actually, they've got quite a luxurious site there. It looks like it's like in Arizona somewhere. Or you're in the middle of a city in Germany on the right. There are challenges in doing this work, but it covers a whole range, we know. So you must and can consider trenchless for any of those, small, medium, or large. And I don't apologise for putting it into that terminology, because I think it's really important to understand the range. So what I'd like to do is, and I'll touch on each one of these briefly. It's small, molding. Probably, I know Roger's on the line from Tracto, but whether it was Russian or whether it was German invention, Roger, this goes back many, many years ago. I think it's 50 or 60 years ago. The most simple technique for molding underneath the ground. But ironically, when we talk to people, and we still see it, people are still cutting trenches across roads, whether it be a small road on a golf course all the way through to an A road or a major highway. We still see it for quite small pipes. and it really isn't needed. So molding is your simplest way of approaching trying to avoid digging that trench. And Roger and Tracto could bore you to death with that history, but it's very important to recognise, even on the smallest diameter, on shorter lengths, that you can use this technology. What I would ask people to do in the chat is, at the end of each one of these, if you've got any questions about the tech, then you just drop a note in there. So that's the kind of like starting point. Then using a similar process of using a sort of percussive hammer type technology, we can then step up. Now, again, often people have forgotten about pipe ramming as a very simple process to install a crossing without having to dig a trench. But these systems can cope with a very large range of diameters. And why bother doing this? Well, if you've got the space, you can adopt this technology. And of course, it's relatively cheap compared with some of the technology I may be showing you later. It can be very effective. And at the end of the day, you're only displacing the sleeve diameter, not the full volume of the earth. So once you've taken your sleeve through, you can then remove the earth, and you've effectively created a sleeve through which you can then pass a conduit. And this can be used for anything, of course. You know, we are literally talking about creating a conduit, which means you can put a cable in it, you can put a pipe in it, you can put it's been used for things like district heating, it's been used for fiber. So again, it's incredibly simple process. You do need the space, clearly, as you can see, but it has been successfully used extensively in the industry over many years. What I will draw you to is a bottom right-hand corner. Slightly odd there. You've got the machines actually holding up a bit of steel sleeve, and you've got a ramming unit being used. And what's that all about? Well, what you've got there is they are going to be proceeding doing a different technology, directional drilling, which I will talk to you about in a minute. They've got a major estuary crossing there, but the first 5 to 6 meters or so of ground is very difficult ground. It's cobbles and various heavy material and gravel, which can be quite difficult to get through initially with a drilling unit. So what they're doing is combining the technology. They're pipe ramming that sleeve through that layer of ground to enable them to then use the drilling rig to go some significant depth and get underneath the estuary with the pipe or the cable they're installing. So this is what I go back to at the start when I talked about understand what you've got, understand your ground conditions. So even when you know, on the face of it, a project could look almost impossible, or could be turned down by a contractor because of the ground, actually there are ways to overcome it. So if you know what you've got, you know your strata, particularly on those sorts of jobs, then there are some very clever tricks and some engineering solutions that combine technology. So again, I encourage you on the pipe ramming, if you've got any questions, pop that in the chat and we'll pick that up at the end. Now we're just going to keep moving up levels, really. So, and again, I don't apologize for going through each one for those who aren't familiar. Auger boring. When I started my career, tunneling kit was extremely expensive. The costs have come down now. Drilling was really, directional drilling, which I'll touch on in a moment, was in its infancy. There was an awful lot of auger boring done. Again, very simple. We're starting to step up with diameters. We're starting to step up with a little bit more sophistication now, where you are using some sort of pilot, and there are a variety of you know, pilot kind of systems that can be used, but you're using some form of pilot to be able to get through to where you want to in terms of from the launch to the reception. Once you've got that pilot, if you just look at those diagrams rather than the equipment, if you look at the diagrams, the first diagram showing the pilot being pushed through, get to where you want to be, and then you use the augers to increase that pilot diameter. So you're then cutting a larger hole and putting a casing through. Once you've done all that, you've got your casing through to your reception area, you're then going to pull back your sleeve. Now, you can either pull a sleeve back, or you can actually pull your product pipe in or your duct in with the augers, or in the instance of the bottom, and you want to do a larger diameter, you might even auger in reverse, if that makes sense. So very simple process, but very effective for shorter punches, going up to some quite reasonable diameters. And again, really flexibility here, because you're effectively creating a conduit to put whatever you want in it. So are you going to put a bundle of fiber in it? Are you going to put a high voltage cable in it? Are you going to put a water main in it, and so forth? So really, you're not beholden to a particular technology. You are just creating effectively a valuable hole in the ground. Again, with these auger systems, they vary in terms of the space you need. And the other thing, back down to my point about ground, and I'll bore you to death with that, knowing what you've got, they'll have different cutting heads for different situations. So if I show you another slide, we're now sort of moving up another level, and you can see different ground being coped with there, a steerable drilling head, a much more compact unit there. So again, they consideration of a sort of a location where they've got a sort of soft rock situation. They're able to cope with that, and they're able to cope with that because they can use through that. And you can see where the guys are stood, gives you an idea of the scale. That's a useful picture, because although the guy's smoking his fag and it doesn't look the safest environment in the world, that does really demonstrate to you the sort of diameter we're talking. You don't have to be talking about really big tunnel equipment. This is at the small end, but extremely useful for the right sort of project to get a conduit through and to be able to put your utility within that conduit. And then this is just to give you a flavor, just variations on the same theme. People have adapted the equipment to be able. Yes, sorry.
Not sure it's just me, but I've lost the pictures.
Oh, have you? Has that gone through? No, you lost it.
I can still see
Me,
Tim.
me too. I've lost them all.
Yeah,
so-
I've still got them, mate.
Yeah, I've got
Like
the
to see
pictures.
them.
Shall I relaunch
Okay.
it, guys? What's the best thing to do? Do you want me to read? Did it just drop out just then?
It hasn't dropped out for me.
No, for me.
I've still got them, Jim.
I've still got them.
Okay, let me go back. Well, what I'll do is, whoever's lost, do you want to reconnect? Maybe it's the connection that's gone down. Hello? Hello, have I lost you?
I think people are coming back in, Tim.
Sorry?
Some people are coming back in.
Oh, okay.
That's better. That's better now.
Can you still see it? Yeah?
I can now.
Okay, cool. All right. So not quite sure what's happened with the connection there. Okay, so just following in again in the auger, looking at augering and that type of technology, you can see here where the first few photographs were showing quite a large excavation. Somebody's been quite generous. Another one which you could question in terms of, is that rock, open excavation. But these systems can be adapted for putting in effectively concrete rings or shields. And as you can see, some clever ways of getting them in the excavation, into a launch and reception using that type of arrangement. The other thing is, I've talked about, you can see something just use a steel sleeve. If you look at the bottom right hand corner, you can see where they've been doing some augering and they're jacking in a clay pipe directly. And that will become the product pipe, the gravity pipe. So there are a huge variety of these and a huge variety of ground that they can cope with. And again, that's why this information up front is absolutely vital to understand their adoption. Okay, so when we've gone from those, I'm trying to step this up really in gentle steps. All these things are determined by the complexity of the project. But what I wanted to do was really make sure people could understand that there are choices before you get into this type of tunneling operation. This tunneling from this particular piece of kit is Japanese, was developed in the 80s, 70s and 80s because there was an extensive need to install a wastewater network in Japan. Japan was not, hadn't got the main sewer network kind of infrastructure that we've enjoyed. It's one of the most highly populated countries in the world, and if anybody's been there, it really is. So they had urban environments where they literally just could not consider and would not consider trenching. So microtunneling in this format with the Isaki mole and was developed for a huge variety of ground conditions. And these systems have proven to be very successful and being applied all around the world. But we are talking now moving up another level, as you can see. But we're also not talking about those really big machines that I showed you at the start. You know, this is still in the micro tunneling territory, but can cope with a wide variety of ground, including some quite poor ground conditions, and can again be used. We might tend to default and think of this being used for wastewater networks, but again, there is no reason why these systems can't be used to create conduits for other utilities. And then we start going into sort of almost an adaptation of a theme here. What's interesting is, and we'll go into directional drilling in a minute, with the advent and the proliferation of directional drilling in the success that it's been, in fact, the tunneling manufacturers have responded to that by adapting their tunneling equipment to be able to do curved drill runs, to be able to put pipes in directly behind. Often these are to do with transmission networks such as gas transmission or water or large diameter water mains. So it's a combining of technologies now. We're seeing sort of the pushing of the pipe into behind the machine being capable of coping with that and being used on quite extensive projects. What we're also seeing is, again, people adapting the technology, which, you know, if you looked at this 40 or 50 years ago, you frankly wouldn't have used this sort of complexity of equipment for these types of jobs. But particularly in mainland Europe with and in Germany, as an example, where they've shut down the nuclear and then shifting where the power comes from, wind farm and various things across the continent, then there are significant lengths and kilometers, hundreds of kilometers of transmission lines, electricity transmission lines being installed. And because of that, they have adapted these tunneling type machines and micro tunneling for use in that market, which myself, I would have thought wouldn't be, you know, I'd be thinking, well, surely this isn't going to be appropriate. But you can see here, this is work taking place. And the trick here is, the benefit is, they are doing bores of 2 kilometers in one shot. So they, you know, you've got a big setup. You can see the photograph there, the setup on this particular job. You know, you can argue that's a hell of a setup for such a small diameter boring operation. But the whole point here is they are going to run that machine for significant distance. And that's where the advantage comes in. And as I say, this is being used quite extensively for cable runs where there's transmission, and it's the benefit of not only crossing under particular problems that you would obviously get on a new transmission line, such as railways and rivers and the usual stuff. What they're doing is, well, we're going to go from A to B, so I may as well do it trenchless the whole way, and we'll have the environmental benefit. We'll also get a huge kudos from customers and planners and people who are objecting to it, because we're going to do it in this way. So, okay, you can see the launch bit there, quite significant. You can see the reception at the other end, but in between, there is no trench. Now I'm going to move on to another bit of tech that's used quite extensively, which is directional drilling. Peter from Volker is kind of on the line. Peter, I sat in his car somewhere. Where are you, Peter? Up in Sellafield, was it?
Yeah, I'm in Suffolk, yeah, around the Suffolk area, sitting in a co-op car parks somewhere where I've managed to find a signal for the telephone.
Okay, and you're not going to move. So what I'm going to do is going to introduce the drilling, and then Pete will sort of chip in as we go. I think the key here is as you reflect, again, for those that are new to the technology, a lot of these new install techniques, the tunneling, it tends to be a single drive. On some of the other technology, you're putting a pilot through, and then you're making sure your pilot goes where you want it to be before you commit to then installing the actual carrier pipe or a sleeve. So again, this is an educational piece, so no apology here for those who are very familiar with this. On the left-hand side, you've got the pilot type of operation. So you can drill through with a small pilot. That could be anything from 2-inch to 6-inch diameter. That will have various sensors on it, depending on the depth and depending on the diameter. So I'll show you some of the variety of drill rigs in a minute. On the smaller end, if you look at the middle picture, on the smaller end of the kind of operation, you actually can have a walkover. You can literally walk over the top of that drill head. You can mark the ground, you can pick up its position, and you can tell the operators the steering commands to be able to steer it. So that's the important thing to recognize. One, you know where it is. Two, you can then alter and steer as you go. If you're talking about deep and more complex projects, then you'll have more remote sensoring to be able to know where the drill head is, and also to be able to steer it. But the principle is exactly the same, whether you're doing a small diameter or a very large diameter. You put your pilot through, and then if you look over to the right-hand side, once you put your pilot through, you then pull the rods back towards the rig that's doing all the operation, and you remount the hole, the original pilot hole. And that can be in a single run if it's a small diameter. You may pull in a pipe directly behind the reamer. With the smaller equipment, I've done that, where we pulled in water mains and gas mains and ducts for cable. In fact, in the States, some of the equipment I used was originally purely for pulling in cable. So it was drill out, ream back, pull in a electricity cable directly behind the reamer. But if you've got large diameters, then it can become more complex, and you might have one or two passes for the reamer itself in order to increase the diameter. And the other thing is, you will be using some sort of, in the industry we call it a mud mix, which is bentonite mixed with you can use various other materials to keep the hole stable and open while you're doing this operation. Pete, just on the kind of methodology, and then we'll flick through some of the different levels. Anything to add to that in terms of method?
Well, it's all, as you've said there, Tim. It's horses for courses, isn't it? And every project is designed on its merit. As an example, the guided auger boring that you were just talking about, it has plus and minuses. The minuses to that you've got to put. If you're looking at that picture with that directional drilling rig now in the centre at the top, at the entry and the exit point, you would have to have a shaft, and that obviously entails a cost. So it'd take you longer to actually put the shaft in, than what it will to do that drill. I mean, a small drill like that, you might just do it in a day, whereas the shafts will have to, you know, it'll take maybe a week for each shaft. But for doing a small rail crossing, for example, you wouldn't be able to get the drilling rig in there, the horizontal directional drilling rig, so the shaft would become the appropriate method. So it's horses for courses. I mean, there's an entry pit there next to the drill rig, down underneath the river and the road, up into the exit pit, a small pipe, like you say, one ream, and pull the pipe in. So it's all about the ground conditions and the space available and what the customer requires.
Yeah, I think it's a really good point.
Yeah, the directional drilling rig, the smaller drills like that are very quick. It's when it gets a little bit larger that they get a little bit more complex, and like you said, your stage reaming, and it's all I can say really is horses for courses.
Okay, I'll flick through then. Again, really keen to show the scale on this, because often within the industry, people are aware of a particular type of equipment, but they're not aware of the range of equipment even within that technology. So if I show you kind of like the small end, what I call small to medium end, again, no apologies for saying that. Top left, you've got a really small pit launch equipment. So again, Pete's absolutely right. When you've got to drop a shaft down, you may have to get down 2, 3, 4 meters or something. That can be a very complex operation in itself. But at this end of the scale, you've got some very simple steering equipment. If you're doing a very short run, it's quite shallow, and it's small diameter. There is some very clever what would be called pit launched equipment. But you can see that gives you an idea of the scale, and that can be very successfully used for a whole variety of things like cable runs, fiber optics, water main services, gas main services, all sorts of things. So even when you're at that end of the scale, us lot in our society get twitchy when people are cutting trenches across tarmac or playgrounds or whatever it might be, when actually you can do it remotely and very easily by having the right equipment. Exactly the same principle. Get your pilot through and pull back your conduit. On the right hand side, you're sort of stepping up a little bit from that really neat equipment, which clearly will only cope with certain diameters and certain distances. You can actually have what in our industry we call mini rigs, which you can see the scale of those. I don't really need to point that out to you. The project on the bottom right is to do with a water supply, and that's going through like a community area, a playground in a school. And yeah, they could have cut a trench through there, and they could have caused chaos for a couple of weeks, and everybody could have got upset with everybody doing that job. But they chose to just drill it with that little rig. Comes in and rubber tracks, put in position. As you can see, there is really didn't even bother with a launch and excavation there because it didn't need to, because it was only a service pipe. So same principle, drill through, pop it out the other side, pull in your service pipe, and get away from the job. And as I said to you before, in some of the projects I was involved with early doors, trying to promote this stuff, we were embarrassingly quick on those sort of types of operation. So again, be aware of it, understand you can use it for some quite clever stuff, and the kudos clearly of not disrupting at all is huge. If we then move up a little bit, and you can scale this is the important message here with this type of equipment, you can scale it. So we're now scaling up, and we can now deal with bigger diameters and longer lengths. But what I wanted to draw your attention to on these photographs are the top left and the bottom right. And there's some irony here with these two photographs. This rig is being used to install water mains down a road. It's sort of partly in the road, partly through the verge. They're drilling probably 100-meter pools at a time. I would say it's probably a 125 or a 180 that they're installing. And the irony here is they were instructed by the Highways Authority to cordon off the area of work in which the mains were being replaced. And you can see the irony. they've actually used the place to put the tanker and the behind the back of the drilling rig there, but actually they could just cordon off that bit. They didn't need to cordon off the whole of the length. So it's quite interesting how a lack of understanding there from the local authority insisted that we are replacing the water main. We want the section you're working on technically coned off. But you could perfectly legitimately do this job. We've shown crossings like what I call the glamorous, the engineering problems, the railways, the canals, the rivers, but you can drill horizontally down a road, down a lane, get it down to depth and install a water main or a duct or install fiber, install whatever it might be, and drill horizontally. You simply go into your reception pit, you level off at the position you want to, and then you drill horizontally and you pop out at the other end. You don't need to be doing curved runs. You don't need to be doing those sorts of things. Highly productive. In fact, so productive that often the street works can't keep up with it. And it's one of the challenges is the fact that the traffic lights are more of a problem of moving those forward than the rig doing its job. I mean, I've done projects where we've managed to get the guy walking down the side of the road and the drill rig is cordoned off and they're drilling, but because the guy's only marking the road on occasion, he's able to step in and step out, and actually the drill rig's working before they've even dug the other pit. So that gives you some idea of the flexibility. Again, this sort of equipment you can use for a huge variety of of utilities. Ground is important if you're doing it this sort of environment in a more shallow kind of ground is really important. Because you've got to be very careful of, the operation. But in principle, you can do this operation very, very effectively and very high productivity as well. Pete, anything to add to those sort of what we would call, unfortunately, the slang we use is MIDI rigs, but anything to add to that sort of operation at all?
No, not really. The exactly what you just said. The first slide you showed was all mini rigs, and you've got these are the MIDI rigs that go up to like 40 ton. Maybe even some people have different explanations of MIDI rigs. You can go up to 80 ton you could still call it a MIDI rig. And then above 80 tons, they become maxes. But yeah, absolutely. I agree. There's really no need to have barriered the whole length off if that's what they've done on that particular project. But and I see there's a nice tractor machine there, which Roger will be really pleased about.
Okay, so now move on to often what people think of. Well, I say often that there is this extreme where these are the big engineering projects. They are significantly complex. They can go into very large diameters. I put 1.5 meter diameter. Maybe you can go even bigger these days, Peter. I don't know.
Yeah, 56-inch one is more or less 1.5 meters. We've just done about a kilometre of 56-inch in Holland, which in a stable formation, you're obviously you're having to cut a hole 1.8 meters and stabilize it for 1,000 meters in order to pull the product piping, which is very technically challenging.
Yeah, and I think that's
but the capabilities there.
The capabilities there, and I think the interesting thing there, if you go through each one of those kind of scales of drilling rig, then you can see that actually it comes more complex, but the benefits are still there. So the very small rigs, they might be able to drill up to say 200 meters. Then the MIDI rigs can do up to 500 meters. When you get up to this scale, this is in single drill runs, and this is one of the big advantages of this particular technology compared with some of the tunneling technology because of the distances. These become significant. 1.5. I mean, I've got 4 kilometers as one that I picked up on with some of these rigs, but significant lengths and scale, which is not often understood. Let me turn this into a bit of reality. Peter, could you just, I'm not sure how familiar you are with these jobs, but whether you could just give a flavour, again, with your expertise to the audience, a couple of these bigger engineering jobs.
The one on the left is actually one of our projects, and that was a project in Scotland. It doesn't actually, the picture doesn't do it justice. The rig is actually sitting 85 meters above sea level at that point. We were drilling down a severe slope and drilling out onto the seabed where you can see the barge there. That was our exit point onto the sea, well, onto the estuary bed at that point. Very challenging ground formations, fractured rock all the way, and gravels on the seabed. It was a very challenging project, but successfully installed.
What was that for? What was that for, Pete? So people can understand.
That's for electric connection. So the cable was then ploughed across to the peninsula. You can see at the bottom of the picture from the circle over to the land. They ploughed a cable into. It was to connect the two islands with electricity. There was 2 ducts installed for that.
Okay,
I think that there were 400 mil internal diameter ducts. Good project. Technically challenging again. The other one, I'm not sure what that was. It's an estuary crossing, I think. I'm not sure if that went out to include the landfall, but if, 520 meters, it doesn't look like it did. It just looked like it was just an estuary crossing. It wasn't one of our projects, but the top right picture you can see there's a product pipe about to be pulled in. I don't know what project that was either, to be fair to him, but that's just
that
the drill pipe and the reamer that's connected to the product pipe.
It was Southwest Water. That was Southwest Water. So that was although it's black at the front end of that toe, you can see in the top right corner that was then welded onto the product pipe, which was I think a 500 mil diameter water main, and you can see if you look on the top left hand corner where it exits, and it literally did exit through the ground. You can see the right hand photograph at the top. You can literally see they drilled straight out of the ground and then pulled it straight back into the ground. If you look on the other small photograph in that corner, you can see and again, this is slightly ironic, is it not? You can see the pipe track where they're going to lay the pipe conventionally by trenching through that through the the cliff top to then put the water main in. So that water main is doing a feed along the cliff tops, coming to the drilling point to get underneath that tidal estuary, and then they're going to move on to do another section. So that again is what I would classically call more of a transmission water main, but the whole technology can be used for whatever kind of conduit you want to do. So this is at the top end, admittedly, of the scale, but I've shown you the other units to give you a flavour for the variety of things that can be done. Peter, anything else to add to that? And then we'll move on to some other bits and pieces before we move on to.
I'll just elaborate one of the points that you made, Tim, about 4 kilometres. 4.5 kilometres have been achieved in Germany now. Unfortunately, one drilling rig doesn't have enough power to drill 4.5 kilometres, but it does have enough pullback capacity to pull back reamers, hole openers and product pipes. So on that instance, 2 rigs will drill and meet in the middle, so each one can drill 2.5 kilometres and meet in the middle, and then one drilling rig can take over from the other one, because obviously just pulling is easier than pushing with a drilling rig, which I don't know if that makes sense to people or not, but it is. And that's where the capabilities come from for the extra lengths. The guidance that we're using now, gyroscopic guidance, it's the same technology that they guide missiles with, and meeting in the middle of an ocean is not unheard of anymore. Okay,
that's really interesting. I wasn't aware of that. So again, that sort of reflects on how complex is the project, what diameters you're doing, and to what degree do you need to tweak the technology to be able to undertake a project. And that's why we always say, our job is to get people thinking about this early and not dismissing it early because they only know one part of it, or they've only talked to one specialist about it that only has one sort of bit of the portfolio. The real key here is to know that the toolbox there's a huge toolbox available to everybody if you want to go trenchless. Okay, appreciate that, Pete. Thank you.
No problem.
What I'll do now is we have got Roger, who's joined us, which is great. Roger's going to do a bit more detail about this, do some slides about online renewal. We thought this was important because often technology or new installation is used to replace an existing asset. But we also want to draw the attention to, well, if it's possible or the option is available, then that asset could be replaced online and effectively renewed and a new asset put in place. So you're not reconditioning it. You're not doing that. You are literally getting rid of that asset and putting in a brand new pipe or whatever, or duct. Indeed, you could have put in a duct with this. So what I'm going to do is going to give an overview, just very quick slides, and then Roger at the end of this chat will then give you sort of 10 minutes on pipe bursting per se, because we do feel, again, technology that's 40 years plus old has been sort of lost over the annals of time. So I'll make loads of mistakes now, Roger, and you can correct them when you do your bit, if that's okay. But in principle, whole range of diameters. We've even seen people, if you look in the bottom left-hand corner, we talked about drilling, use mini rigs to do this. In reality, you don't need to do that. There's lots of perfectly good hydraulic equipment which is better suited to do it. But yeah, there's different ways to replace online. So I'm going to give you a couple of quick examples. So now, whether we regard this as pipe bursting or whether we regard it as pipe extraction, I don't really mind, because it's really doing the same principle. This is a way of extracting services. It was developed for lead renewal, but it doesn't have to be lead. It can be any sort of small diameter conduit, because this is very clever. What this does is it goes. You take a cable through the original, and then you attach it to the original. And as you pull the original service lead out, you pull in your new service. Very clever, very effective. Clearly, you've got to have operators who know what they're doing in this environment. You've got a there's a lot of hydraulics going on here, and you need to be safe in that environment. But this has been used successfully and extensively. So it's a really simple way of withdrawing a service, an existing product there, the service pipe, gas, water, typically, but renewing it by using this pull through or extraction type of process. If I know so, because I don't do too much detail on this with Roger talking to us in a minute. If we now then look at pipe bursting, we call it pipe bursting, pipe splitting, various bits of terminology, but it's all the same stuff. What I wanted to draw your attention to here is the left-hand side and the right. The left-hand side, a lot of people will, if they consider it, and as I say, it goes back a long time, pipe bursting as a methodology. British Gas, as was Northwest, patented it with a company called Ryans back in the 80s, and it was used extensively to replace the gas network in the UK, extensively. So when people are nervous about it and kind of like, well, this is just so new and innovative, no way would I ever do that. I mean, I'm talking hundreds of kilometers that were replaced using this technology. So, but that does tend to make people think about small diameter. It does tend to make people think about cast iron pipes, because they're brittle and so that they burst really easily or fairly easily. But that's fine, 4-inch, 6-inch, extensively used. But if you look at the middle picture and then you look at the right-hand side, it can be used for larger diameters. It can be used for other host materials. And the one on the right I want you to draw you to is a main sewer, a concrete sewer, quite large diameter. Again, bursting has been used to replace that pipe in an environmentally sensitive location. So, and that's on waste. That's a wastewater sewer, as opposed to as opposed to a water or a gas main. But of course, if you've got ducts that you need to be replacing, you need to take cable out, you need to, it's perfectly suitable to be using for that. Often people have said, or in the past have said, well, yeah, but you've got to displace the ground. No, you haven't, because if you think about it, the pipe is already there. There's a hole in the middle of it. These pipes have been laid, or ducts have been laid in a trench originally. Often that trench, let's face it, however well you try and compact it, isn't fully compacted. So when you draw these machines through, obviously you've got to be sensible about how much you do this and what scaling you do in terms of when you do the replacement. But the ground can take some compaction, because ultimately your pipe or your duct is sat inside a not 100% compacted material. So there is some give there once you've broken the existing pipe, and that allows you to pull in your conduit or your duct. You can obviously just pull in a duct, and then you can thread a pipe through if you want. But most of the time, people put the product pipe directly behind the bursting head. Just a nod to Renewal, new stuff. The simplest way of actually doing it online is to slip line. That's just put a plastic pipe inside a pipe. But of course, you lose quite a lot of the diameter. But again, these technologies went back a long time ago, where people say, well, okay, well, how do I mitigate that loss of diameter if I'm slip lining, if I'm simply installing a pressure pipe inside another pipe? Well, there's lots of technology around to reduce the diameter of that pipe, pull it through, and then allow it to contract back. So you get what we would call a close fit or a tight fit. And because of that, and because of the coefficient of friction of the plastic compared with maybe an old cast iron pipe, and you've removed all the iron nodules through cleaning before you do this operation, the hydraulics can be the same as the original, because you've got a much better pipe that you've put in, a modern polyethylene pipe, which is very robust. And then the other thing people say, well, you couldn't use it in an urban environment. Just wanted to show you this. This is Thames Water doing a project in London, highly urbanized area. You can see the picture, the screen grab at the top right. A lot of disruption when they had the pipe string, absolutely. But this was the project I mentioned earlier. Would have been a 3-year project, and it was done in 9 months. And that's because while they were doing the work, they were doing pulls of around about 600 meters in one pull on something like a 600 to 800 meter diameter pipe. Frankly, where this pipe was, and its close proximity from the Victorians putting it in alongside, 5-story, very nice buildings, open cut probably on a lot of the sections wasn't an option. They were going to have to reroute this for kilometers to get it to where they needed it to be for the supply. So really interesting way of online renewal or new. Would have been too complex for drilling, too difficult, too expensive for tunneling. So this was another alternative that was adopted, and I think is in phase 4 with Thames Water at the moment. And then I pause. I'm just going to show you very quickly just 1 or 2 other things. We're just after 3 o'clock, so I'm just going to pause slightly and just show you some quick other things. So mole ploughing, if you're not familiar, used extensively in the fibre optic market for installing fibre optic, literally as it says on the tin. You can see the picture on the right there, which has got, if you look carefully, you can see a little reel on the right-hand side of that piece of kit from Vermeer. That's for putting your drum of cable, and that goes threaded back through to the plough at the end that's hollow. And then you literally, as you can see on the left-hand side, drop the plough in and go through. Very simple, very straightforward, very effective in that sort of environment, fields, agricultural land and other things. So really simple way of doing a job that otherwise could have been quite disruptive. Really primarily used by anything that's cable orientated, so fiber and for electric cable, but can be used clearly for smaller diameter polyethylene based pressure pipes because of that flexibility. But the rigs will change, vary. Obviously not so easy if you're going to start putting in bits of pipe, because your reel becomes quite complicated and quite difficult, and rigidity of the pipe becomes a problem. So cables particularly are used with this sort of fairly simple technology. We're not quite trenchless, but we're doing pretty well. Don't want to go into detail, but similar concept. If you are going to do it trench, do it narrow. These systems, though, they are cutting through everything. So real big warning here. Can be very effective, can be hugely productive, but you really need to know what's in front of you with these types of systems. If you think about it, drilling, bursting, even those, you're going underneath things that cross over you, but these are literally cutting a trench, so you have to be very careful. But they have been used very successfully on the right sort of projects. And then finally, to sort of wrap up this section, I did want to give a little nod to vacuum excavation for those who aren't familiar with it. Again, we can shoot ourselves in the foot by talking about it being really innovative. It is really simple. You are extracting by vacuum and using water or air to remove soil. Really, really useful for very congested areas, and often combined with the trenchless, some of the trenchless technology I've talked about already. So those that are really progressive in the market will use vacuum excavation at the launch and reception to really make sure they're maximizing the sort of minimum excavation that they can do. The other thing, in an urban environment, it is so much tidier. You haven't got to move stuff around. The photograph I've got here on the left is quite a big rig, but similar to trying to show you the variety of equipment, you can have very small vacuum units as well. And projects have been done with this sort of equipment for installing water meters, for example, just to give you a flavour. So I just wanted to give you a flavour of that before I finally close, which you'll be relieved to hear. Just a nod to a number of people who've photographs and illustrations that I've pinched there across the market, just to give you a sort of flavour. There are a lot of different companies out there with a lot of very clever kit that's available. So what I would like to do now is to take a breath. I'll pause. We'll have a look at the chat if there's anything in there, and then we'll get Roger to join us to talk through the pipe bursting itself. So let me exit that, and I'll drop that down and drop that down, and then I shall come back into the Okay, so I don't know whether there's anything in the chat. Let me have I've got to open my chat up. No, we haven't got any questions in the chat at the moment. Are there any sort of key questions now? But will we have an open forum at the end? Is there anything particular, any burning questions following that canter through? Nope. Okay. In which case, Roger, can you give us a deep dive on the online renewal piece for sort of 5 or 10 minutes, if that's okay? Can you share this? Are you okay to share and do that, Roger?
Yep, let me just quickly put it on presentation mode and get it shared, and I'll be starting in 1 minute.
Okay, thank you.
Okay.
Say, I don't apologise for going through all that. It is an education piece here, and I hope that that's helpful to show the broad range of opportunities there are to use trenchless.
Tim, there is a question in.
Oh,
Okay, Roger, could you just pause 1 second? We've got a question there.
Absolutely.
Yeah, Peter, we've got sort of standards in terms of directional drilling, angles, vertical and horizontal. Any feedback you can give on that in terms of standards themselves?
The vertical drilling is different, completely different to directional drilling. I say completely different. The methodology is similar. The maximum angles that we tend to go is 45 degrees. So we have a project in Wales a few years ago. We drilled up a mountain at 45 degrees for 500 meters.
But that
So
would
it
be
is possible.
You could do a shallower drill angle than that, though, couldn't you? If you wanted to.
Yeah. Oh yeah. Most drills are between 6 and 15 degrees.
And then the other
Exit
beauty
under
is, just to add to that, on the angles, this does go down to what you're trying to achieve and the layout of a job. What you can do is we maybe not made that clear. What you can do is classically, in some ways, it's our own fault for the diagrams that are produced. Often we show these curved diagrams that you go from one, you curve through, you go. But what you can actually do is you can drill down to a position, then you can drill horizontally, and then you can drill out and come out. So you don't necessarily need to be doing a sort of bell curve. You can do variations of a theme, and you can also, within reason, depends on ground, depends on steering, depends on distance, you can do some variations within that drill run as well. So in the past, I've done things where somebody said to me, I need to cross this, it was a railway, I think it was, yeah, railway. And I said to them, what are you doing? Like, there's a canal, which was about another 40 meters on, and there was something else. And they said, oh, well, we're doing that as a separate, that's a separate crossing. And then what was fascinating there was we were able to start drilling in at one point, go in at that sort of 15 degrees, level off, drill underneath the railway, bring the drill bit up, and then drill again to go under the canal. And it was about an 85-meter kind of drill run, but we had varied those depths as we drilled it because the ground conditions were favorable and all the rest of it. So you can do some very clever stuff on angles, and where you set these drill rigs up and how you approach the job. You're not beholden to a bell curve necessarily. On the bigger stuff, you've got, as Peter, I think it'd be correct to say, a bit more restricted on the bigger stuff because you've got the stiffness of the rods and you've got less flexibility. The smaller stuff you can be quite flexible. Would that be true to say, Pete?
Yeah. The radius of the bend radius of the equipment that you're using. So, like exactly what you're saying, on a smaller drill rig, like a mini or a midi drill rig, you've got a more. You can achieve more with the bend radius. But when you're doing larger maxi drills, you've got like 8-inch drill pipe. Your drill pipe is actually 8-inch in diameter. Your radius is restricted. The other downside to having shallow angles at an exit point, especially if you've got a 6-degree exit angle, for example, we're working under the mud pressure within the drill pipe is quite high, and it tends to frack out into the area. So you get a mud frack out before the exit pit, and you don't want that. So that you try and you design the project around the ground conditions and what's required and what's achievable.
Okay, and we'll just pick up the second question and then we'll move on to the bursting. Also, for vertical clearances below existing, so is this or is there a industry standard? Pete, I mean, with your stuff, I don't think that's going to be relevant, particularly. We haven't got others on the call, but from my experience, we generally used to say it's something like a 300 mil gap. It does depend on the diameters that you're talking about, and so clearly if you're putting in a 90 mil or a 125, then you can run quite close. If you're putting bigger diameter, you've got to be careful. The other thing that you can do, and again, it's approaching these jobs in a very flexible way, is even if you're drilling 100 meters, say small diameter, particularly if you're talking about utility crossing over where you are drilling, to give clients assurance. I've done that in the past where I know I can drill 100 meters. It's straightforward, the ground's acceptable, everything's good, but there are a number of pinch points. Then, of course, if you have something really critical that you're really nervous about, why don't you do a vacuum excavation at that point? If you're only talking about a meter and a small 1 meter by 1 meter hole, you just take that hole out. And I've done that before where clients have said, well, you know, they're really nervous about, they've got an electric cable or they've got maybe a gas main that, well, I know I'm comfortable doing it, but if you're not comfortable, just drop a very, very simple excavation at that point. And all you do is the drill bit is you just drill straight through it. And then you drill, and then you ream straight back through it, and you have to backfill the hole. Slightly embarrassing in the sense that you've dug 2 holes, maybe if it's 2 locations that are of concern, but you can still pull the 100 meters. So that's again, it's thinking slightly cleverly around how you approach the job, rather than saying, oh well, you know, there's a high voltage cable there, we don't know where it is, we're really nervous, we know it's across here. Well, if you're digging a trench, you would probably want to know where that was. So you often, what happens with trenchless is we find reasons not to use it, but then we forget that trenching is by no means perfect. In fact, there are huge benefits to going underneath all those things. So although you're quite right to point out, Darren, the you know, well, where's the safe distance? You know, that the potential and risk of damage by trenching is still there. An accidental, you know, we all know when people trench and everybody knows where it is, but we still manage to hit it. So I think it's just sort of weighing up those 2 risk profiles. And as I say, if you've got something really you're very nervous about or very critical, then well, why wouldn't you just drop a pilot at that point? You can keep it really tight, and then the drill guys will just drill straight through that hole and straight back again. Okay, so without further ado, Roger, hopefully that's got you teed up to do your slot. Are you okay to start now and share the screen back?
Yes, I am. Okay, before I start, I couldn't agree more with Tim. Safety first. If you're unsure where the other utility is exactly, do a little excavation there, safe excavation, and expose it. Because one thing is for certain, if you hit it with a drill rig, people are going to say, oh, well, you know, drilling is too dangerous and we don't know what's in the ground. If you hit it with a digger bucket, people are going to say, oh, well, that can happen. And that's just a sad truth about, you know, trenchless solutions. Some people still think that we're dealing in alchemy when we're not. So without further ado, let me just try and get my, what's its controls are. Oh, well, doesn't matter. My Teams controls are right in the middle of my screen and I can't move them. Doesn't matter. So thank you very much, Tim, for giving us some really good overview of all the various on-run renewal techniques. I want to home in to one in particular. My name is Roger Wahl. I look after Tractor Technic UK Limited. Lots of people know us better for the guys who do the mole, as Tim also pointed out. So we do the Grunder mats, but also the Grunder winches and drills and pipe bursting machines. And there's various types of pipe bursting, but again, in the interest of time, I just want to concentrate on one type, which is the static pipe bursting. And when should you consider static pipe bursting? Well, ask yourself 5 questions. What do I want to achieve? Improved volumetric flow rate, improved flow rate in general, reduced leakages or seepages, increased capacity, or re-establishing static parameters, or having realignment of a pipe. If the answer to any of these 5 is yes, then pipe bursting could be the best option for you. I say could be because it doesn't necessarily have to be. If you need to increase your capacity, and with that you need to increase your pipe size, pipe bursting is often the only alternative to trenching. So how does pipe bursting work? I hope you can see this little animation of the screen, but on the screen. But basically, you have an entry pit and an exit pit. So you expose your pipe from where you want to start to where you want to finish, where it's most damaged, and you first feed a set of rods through the pipe. I hope you see that on your screen. Then when they come out at the end, you attach an expander and just pull it all back. And whilst you're pulling your rods back, you are installing the new pipe in the path of the old pipe. Now this is quite simplistic, but I hope it's given you a little flavor. So in other words, pipe bursting is nothing other than the application of brute force. We can pipe burst to install pipes with the same diameter or with a larger diameter, but we can also use it for simple pipe rehabilitation and in the NtTIN pipe or relining technique. It can be done with a pipe burster, but it's not always the most economic way. So generally we concentrate on larger or same diameter pipe replacements. By far the biggest volume of the jobs done is like for like replacement, where the new pipe has got exactly the same inner diameter than the old pipe. It is fairly well understood how to do an upsize to around about double the diameter. But when you go bigger than a double diameter and upsizes of up to 3.5 times the original diameters have been achieved, then it's always good to involve our global product specialists here in the factory. We have got quite a wealth of knowledge because we have been involved in pipe bursting for over 45 years. But as Tim quite rightly pointed out, in the beginning of these 45 years, we used to pay license fees to British Gas because British Gas had this technique patented. So there's a simple checklist that you should go through when you contemplate a pipe burst. And I think some of these also apply to any other trenchless technique. But first of all, it is always really, really good to know what your existing hose pipe is, what profile it is, because we can not only do round renewals, but also oval. You need to know the pipe material that you're dealing with, and then you need to know what the proposed new pipe is, what dimensions, what material. You need to know the position and the course. You need to know of any bends, branches, or the lateral connections, whether it's in the walkway or in the road. And then comes the really important bit. Hang on. You need to know how deep your pipe is, what other infrastructure is around it, and the surrounding ground conditions. The bedding material of the existing pipe, soil conditions, where the water table is. All of these are very, very important because if you think about it, if you install a like-for-like pipe, so exactly the same diameters, inner diameter, outer diameter, you still have to use an expander in front of the new pipe to break open the old pipe. That is around about 30 diameters, 30% bigger in diameter than the pipe that you're installing. So you do have a little bit of ground displacement. Again, Tim was right in pointing out that sometimes the material can still be compacted, but as I said earlier, better safe than sorry. better safe than saying, oh, you didn't see what was in the ground. How could you do things trenchlessly? So we have some simple rules of thumb. You can calculate the expected displacement of the soil, and you need to be 10 times that displacement away from the upper surface, and 5 times that displacement away from adjacent infrastructure. I won't bore you with the calculation, with a formula. We'll do that some other time when we go even more into depth on this one. So, safety first. You need to know the location where you're working for site access, reasons for the replacement. Is it cracks, corrosion, deformation, breakage? All of this has got an influence on the type of tooling that you use. You must know whether there's been previous repairs and rehabilitation, whether you are likely to encounter repair clamps, for example. And if you can it's always good to get a CCTV survey or some other inspection. And last but not least, make sure that you've got all your permits before you start the job. So I think it's fair to say that we at Tractor have probably got the broadest range of pipe bursters on the market. You see here a lot of numbers. It is really quite simple. As a rule of thumb, the number that you see here divided by 2, as a rule of thumb, that's the maximum diameter that you can install. So the 2500G, which is a 250-ton pipe burster, can go up to roughly 1.2 meters. And the smallest pipe that we can burst is a 50 millimeters, a 2-inch pipe. Below that, there needs to be other ways because we've got to get some rods in there somehow. When it comes to the materials that we can pipe, it's fair to say that we can practically burst anything: stoneware, concrete, asbestos cement, reinforced concrete, cast iron, ductile, asbestos, I've already said that, sorry, PE, PP, PVC, glass fiber, reinforced, steel, pipes that have already been lined. When it comes to the materials that we can install, again, we can install round, oval, short section, or continuous coil. Obviously, when it comes to stoneware, you'll be hard pressed to find some continuous coil, but you know what I mean. So anything is possible. For everything, there's an appropriate accessory to achieve that. Nowadays, most times we just pull in PE pipe. There's a wide variety of tools. Some of them have been around for a long time. These expander heads and these roller blades to cut open ductile material. Some others have only just recently appeared. This 4-blade cutter here is specifically designed to burst a PE pipe. And yes, we are starting to burst a PE pipe that's come to the end of its service life. Some more impressions of different tools: double delta blades, single delta blades. Here a little in the middle, a little impression on the sizes that these can have. And now some typical setup. You want to make sure that you shore the equipment very, very well. This is a small 40-ton burster, but you're still pulling a pipe with 40 tons. And if you haven't shored your machine appropriately, then you will pull your machine into the ground, and that's not advisable. Rather hard to get out again.
4 o'clock.
Uh,
Don't know whether
Just-
Mum's coming with us or whether we're meeting her there.
just very, just
after
very
maybe?
quickly.
Hello,
Sorry,
could somebody mute, please? Thank you. Go on, Roger. We lost you. Roger, you're on mute now.
Right, I'm off mute now. Again, sorry about that. So yes, just very, very briefly, other than breaking up the pipe, we can still do some rehabilitation. Here, I don't know whether you see this really well. We've got an attachment on the machine that scrapes out an existing pipe. Or we can do what we call caliber pipe bursting, where we recalibrate the diameter of the pipe and then pull in a slightly smaller diameter pipe. And that is something very topical at the moment, gaining loads of traction, certainly on the continent, but I'm sure it'll happen in the UK as well, the so-called NtTIN pipe, where new short section pipes are being pushed into an existing pipe, but often these pipes, if they have larger deformations, they need to be re-rounded before the new pipe can be pushed in. Quite interesting. Increasingly, people will, as part of quality control, will want to know that during the installation process with pipe bursting or with HDD drilling, you haven't overstretched the pipe that you've put in, and there's a way of tensile force measuring and data logging. So you can put one of these load cells between your pulling head and the rods, and with that measure the actual force on the pipe during the installation process and record that along the distance of the installation process, and then get a printout to guarantee to your asset owner that in the installation process the pipe was not pulled with a larger force than the specification allows. So just one or two impressions of pipe bursting. Pipe bursting can be undertaken in rather tight places and cold temperatures. This is a job in Stockholm that was undertaken some years ago, and also working in really wet conditions around about the water table is possible. This is an impression from just outside of Miami in the States, and again there it gives you an idea of the diameters that were being achieved there. So the machine is fairly robust and sturdy, and I hope that gave you a nice little insight into that one technique. And we believe that the future of infrastructure renewal is trenchless.
Thank you, Roger.
Any questions?
Do you want to unshare now? And then we have got one question in the chat that we can pick up on. So in the chat, we've been asked, is there a risk of the new pipe being damaged by shards of the burst pipe, as in after the, the hose pipe has been split open and cracked open?
I would be lying if there was no remote risk, but to be honest, I haven't in the 10 years that I've been in trenches, I haven't heard of this. I'm sure that there could be some outside scratching. It is just normal when you go through that kind of an environment, but the risk is very, very, very remote.
I can add to that. I mean, what's interesting is when I'll cough now, say how many years ago when I started with pipe bursting. Literally my first job was sent out to do a pipe bursting job in the Northwest. And when that was first started and developed, what used to happen is that the pipe was sleeved. So originally they put, before there was a level of competence with PE, and you have to remember this goes back over 40 years ago. They used to sleeve it. So they used to put a sleeve in, then they used to put the hose pipe inside the sleeve. Bearing in mind its use, this is gas mains. So what British Gas did, they did some trials themselves. They were really hot, as you can imagine, and still are today on R&D and standards. And I would suggest that whoever's asked the question, try and dig out the current standards. I think it's under IGEM, Institute of Gas and Engineers and Managers. I think IGEM hold the standards. There will be one, I'm sure, for pipe bursting. They did various trials, and they found that the scarring on the outside of the pipe had such little effect on the polyethylene that they were confident to then move from sleeving it to installing it directly. That was one thing, so worth a check, but I know that it was unsleeved during stages of that major program. The other thing is that some clients will, there are two options. There is pipe available. I might get this spectacularly wrong, but it might be worth checking with PE 100. I think that's one of the plastic promotional associations, where you can have a protective barrier. So you can have a polyethylene pipe where they put an additional extrusion, I understand, on the outside, which is effectively sacrificial for pipe bursting. That's another option. And then the third option is I've known people to uprate the pipe that they're putting in. So again, they can pipe burst direct, where they need 6 bars, so they put a 10-bar pipe in again. So the wall thickness in polyethylene determines the pressure rating and the ratios of that thickness. So again, people are almost over designing the pipe to allow for some external scratching of the pipe. So on the face of it, I remember those early days where it was like, how can you do this? But we were doing it on gas mains, and all those things were thought through, and eventually we ended up with putting the polyethylene in directly. So might need to do a bit of homework. Maybe if Lynn, you can make a note on that. I'll see if we've got some other experts and contacts that we can check on that. But there are ways to sort of put in additional safeguards regarding that particular question. Hope that helps.
Thank you very much. That was really good, Tim. Thanks. This is the difference between 10 years of experience and 40 years.
Yes, indeed. Yeah, scary, isn't it? I just think it's important to recognise it was used for gas mains, and those are singularly, you'll all argue between you as utility companies and network guys which one's the most dangerous, but certainly the whole reason for the programme was because of leaks and explosions and things. So that's where the iron replacement program came from originally, was because of the danger of the stuff. Okay, so I have got a slide that says kind of open panel. I don't think we need to put the slide up to know it's an open panel. We've got a little bit of time left. Are there any more general questions, whether it be about what we discussed today or just general questions that people have got in their minds? We haven't answered them, or we haven't touched on any technology and they've got something they would like to check. Please do pop something in the chat or stick your hand up. Looks fairly quiet to me. I'm just flicking through no hands, nothing on this. Can you see anything, Lynn or Silvana?
No, it's all empty.
Okay, so what I'll do is I'll do a final share just as we close then, and I'll invite Silvana. Is anything else to add at all before we close? And then I'll put some diary dates up for everybody.
No, I don't think so. Just a reminder of the future dates, and yeah, thank you for everyone for joining for the first meeting of 2026.
Okay, Peter, anything else to add before we close? And then I'll stick up this diary note.
No, nothing from me, Tim. Thanks everybody who's taken the time out to join us, and look forward to speaking to you again soon.
Okay, so let me just see if this will share, hopefully. And if you just bear with me, you should all see each other there. And is that sharing okay, guys?
Mm-hmm. Yes.
Okay, so just to close, again, from me as Vice Chair of the Association, thank you so much for joining. A lot of ground covered. Hopefully you've picked up some new stuff there. We've tried to give a few examples as we've weaved through the technology. I really would implore you to have a look at these dates. This will obviously come through on the recording, but there are loads of opportunities in 2026. We've got a big program coming up. If you are somebody that continues to work and are interested in the renewal and the new stuff, how do you do it? What do we do? We have got a masterclass on the 29th of April where we will have experts across the whole of that field that we discussed today. So we've got some microtunneling guys, we've got drilling guys, we've got bursting guys, all sorts who will be in the room with you, and that's a one-day event. So if you've got projects coming up and you're really, this is really where you want to have a look technically, I would really ask you to, ask you to consider that event, which will be taking place in Leamington Spa. I think that's right, is it, Lynn?
It is, yeah.
Yeah, at Leamington Spa in the UK, face to face. So that we've had these sort of specialist events, and networking and talking to others is hugely powerful at those events. And there's the rest of the program for you. So if you want a lighter touch, there's plenty else going on. And the other really big one, all those are important, but the really big one we would ask you to look in your diaries is the September one, 29th of September to the 1st, No Dig Live in the Warwick area at the, is it the Warwickshire Showground, Lynn? Is that right?
Stoneleigh Park, yes.
Stoneleigh Park. That's a huge event. Lots of exhibitors, a lot of people milling about, loads of questions you can ask of people. So I would say those two might be ones to note for your diary. But we'll leave that up, and we thank you very much for joining us today, and have a good rest of the day, what's left of it. Cheers.
Thank you.
Thanks.
Thanks, everybody.
Thank you.
Bye.
Cheers.
Thank you.